Let's do some rotational motion problems. Let's say we have a wheel that's rotating at 7 radians per second, and it has a radius of 30 centimeters. Let's find the angle it rotates through in 5 seconds. Omega is the rate at which it rotates. It's theta per time. Rearranging, plugging in the values, we get 35 radians. That's the same as 5.57 rotations. Now let's find the arc length traveled in 5 seconds. Theta times r equals s. Plugging in the values, we get 1,050 centimeters. Remember now, radians does not belong in the answer. Radians is what we call an assumed unit. It doesn't really exist. It's just a way of telling us that we're measuring the angle as a ratio of the arc length to the radius. How far would this wheel roll? Well, if it's not going to skid, the distance it travels would have to be equal to the distance along the outside edge. It'll still be 1,050 centimeters. Find the velocity of the center of mass. Well, the velocity is a distance per time. The wheel traveled 1,050 centimeters in 5 seconds, and that's 210 centimeters per second. That's the velocity of the center of the wheel. That's how far it traveled in 5 seconds. Well, is there another way of getting this besides distance over time? Let's try omega times r equals v. 7 radians per second times 30 centimeters. Hey, we get the same answer either way. Keep in mind that this is really a tangential velocity. That's how fast the wheel is traveling out on the edge. When I put the wheel onto the floor, if I don't want it to skid, the whole wheel has to go forward at that speed. Okay, a little skeptical? You don't have to believe me. I gave you a little top. Imagine this thing is rotating. Now put it on the table. Circumference carries it forward. That's why you were rolling that can and measuring how far it went. Now put a little velocity to it. We can spin it. It takes off. Yeah, it was skidding at first. But if it doesn't skid, the tangential velocity is going to be equal to the velocity of the object. So imagine I was spinning this top such that the tangential velocity was 5 meters per second. Now I put it on the table. That point will be skidding backwards. How do I stop it from skidding backwards? I need a velocity of 0 here. It can't skid. How do I go from 5 meters per second backwards to 0? I have to add 5 meters per second in this direction. That means I have to add 5 meters per second to the entire wheel. That means this point, and this point all now have to have an extra 5 meters per second going forward. That means the top of the wheel has to be going 10 meters per second relative to the table. The center of the wheel will be going 5 meters per second, and the bottom of the wheel will be going 0 meters per second relative to the table. So now we have a wheel. It's going to roll and it's going to go across the table. I want you to trace the path that this dot makes as this happens. Give it a shot. Could it be choice A? Could it be choice B? Could it be choice C? Let's try rolling this tuna can across the board. Now you can see that the edge just traces that green line. When it comes down, it touches, and then it lifts off. So why does it come down, touch, and lift off? Well, we said there can be no skidding here. There's no skidding when it touches. Here, it would be coming forward and skidding forward. Here, it would come down and skid backwards. This is the only path that it doesn't skid at. This is a cycloid. Okay, so here we have an angle we've rotated through. If I maintain the rate of rotation, we have a constant angular velocity. But what if I make this thing go faster and faster? Well, now I've got an angular acceleration. Well, let's say we have a turntable and it has an initial angular velocity of 0. And it rotates through 10 radians in 4 seconds. What's the average angular velocity? Change in angle over change in time. That's 2.5 radians per second. What's the final angular velocity? If we assume a constant angular acceleration, we can say the average angular velocity is the initial plus the final divided by 2. Hey, the initial is 0, so the final is just 5 radians per second. What's the angular acceleration? That's the change in angular velocity and the change in time. We have both the initial and the final angular velocities. Plugging in the numbers, we get 1.25 radians per second squared. That means we're going to gain 1.25 radians per second every second. We're speeding up. Could we have also said theta equals 1/2 alpha t squared? Plug in all your values. Hey, it all works. You'll see plenty more like these on the worksheets. Go practice.